So 5.1 Intro to Polynomial Functions. Okay, so I want to talk about constant function. A constant, when I see the word constant, I just think a number. It's always the same, it's never changing. So if I have a function that's a constant, that's like some number like 7. Okay, so f of x equals 7. If I were to graph something like this would be f of x is a fancy way to say y equals, right? So that's y equals is a horizontal line right here at 7, okay? 0, 7 right there. All right, a linear function. So linear function, this is also a line, but this line it does not have a slope of 0. It's not horizontal. So say I have something like this. F of x equals some number. So maybe like, I don't know, 2x. And then plus another number. So maybe like minus 7 or minus 1. That's fine. Doesn't matter. Okay, it's just a number. So how do I graph this? How do I graph this function right here? First thing I do is I look at the intercept, -1. So I go down to -1, okay? So 0, -1. And then I look at my slope. So this is of the form f of x equals mx plus b, where m is my slope. The number in front of the x is the slope. Slope is rise over run. So if I have 2, that's 2 over 1. So I go up 1, 2, and I run 1, and I put a dot. And I do this, and I just keep doing it over and over. Go up 2 over 1, up 2 over 1, up 2 over 1. You can see how that works with your little picture there. So that's a line, that's a linear equation. Linear, it's degree 1. Okay, a constant is degree 0. There's no x term, it's x to the 0 there, so it's a degree 0. All right, what's next? After that, a quadratic. So f of x equals, let's just say, x squared plus 3. That's fine. All right, we're just making something up. So what does x squared plus 3 look like? A quadratic. Right here. This is going to be move up 1, 2, 3. So 1, 2, 3, move up 3. So 0, 3. And then x squared. There's a positive 1 in front, so positive means that we're happy, and behavior is the same for both sides because it's an even degree. So it goes up just like this, okay? So that's a quadratic function right there. So let's talk about all the different behaviors, okay? The degree here. Well, if I look here, the exponent is a 2, so that degree is a 2, okay? So these are examples of polynomials, just giving you some introduction there, okay? What I will tell you is the most dominant term dictates what the whole function will do. So the most dominant term on the first one is just that constant. That's all there is, okay? So it's just this horizontal line. But the next one, the most dominant term is the 2x. The 2x tells me that I'm sloping at a 2. I'm not just paying attention to the 1 there. That -1 isn't the most dominant term. That's why it's not some horizontal line again, okay? The dominant term on this last one is the squared term, and that's what makes, you have this U-looking shape going on here, okay, for the squared term. All right, so let's talk about end behavior. Let's talk about end behavior. End behavior this is determined by the lead term. So just like we talked about right here, the biggest, strongest, dominant term tells me what the shape, the overall shape is going to look like, okay? So it's determined by the leading term. The leading term tells me what the whole thing is going to do. So leading term is like a number and then the x to the n. Okay, so this is some number x to the n. That's my leading term there. All right. So for that last one here, the number in front, so for x squared plus 3, the lead term was x squared. That number in front is a 1, and the n is equal to 2. Okay, so right here, a was 1, and n was equal to 2. So let's talk about the different cases going on. So there's 4 things that can happen for an nth degree polynomial. 4 things. One of the things is this. N can be even or n can be odd. Okay? You can either have an even number or you can have an odd number, but you cannot be even and odd at the same time. So we're talking about this right here. So n is an even number or it's an odd number. Now, the other thing about it is the a value. The a can either be positive, a positive number, or the a can be a negative number. Okay? Those are your 2 scenarios. So this makes up 4 different cases. Okay, 4 different boxes going on here. So how's this going to work? So I'm going to draw 4 little graphs in here. And we're going to talk about the end behavior of those graphs. Okay? If my n is even and my a is positive, so that means we're in this first region right here. Okay? What's going to happen? What is going to happen in even and a positive? That would be like this scenario we just had here. That'd be an x squared term. How does the x squared look? Well, it looks like the end behavior, both sides are going up to positive infinity. Okay? So the end behavior, positive infinity on both sides. Okay, positive infinity on both sides. All right? Now, what happens in the middle here? Nobody knows, right? But we're talking about the end behavior. Okay? How do we know? Even tells me that it's the same. So either they're both plus infinity or both negative infinity. But even in even is the same. Okay? So even is the same. Now, if it's a is greater than 0, we're going to positive infinity. But a is negative, what's happening? Instead of positive infinity, we go to negative infinity on both sides. So what happens in the middle? Nobody knows. But the end behavior is negative infinity on both sides. Think about it like this. If a is negative, instead of having like an x squared term, maybe it's like negative 3x squared. That negative times a positive makes a negative number. And it's a really big negative because you're squaring that number, right? So you're going down to negative infinity. Okay? Now, the last scenario here is when n is odd. If n is odd, so I have like a x to the n is odd, so like ax cubed. Well, think about x cubed. Odd means opposite. Odd is opposite. That means if one is going to positive infinity, the other goes to negative infinity. They're the opposite directions. So if a is positive, the right-hand behavior is going up to positive infinity. Always look at the right-hand behavior first. So opposite of positive infinity, that means the left side is negative infinity. So how these connect, nobody knows unless we're given more information, but we do know the end behaviors. Okay, if I had a negative number, so maybe like negative 2x cubed, okay? So what is the right-hand behavior going to do? Well, the negative pulls me down to negative infinity. So negative infinity on this side. The odd power tells me it's opposite, so it's not going down on the other side, but rather it's going up to positive infinity because it's the opposite, right? So something like that. Okay, I hope that this helps out when you're asked, you could be asked, what is the right hand behavior? Sometimes it's abbreviated RHB, okay? So that's on the right side. That's what we always try to figure out first. Because if it's a negative number, it's going to negative infinity. If it's a positive number, it's going to positive infinity. Okay? The coefficient in front. All right, guys. Hope this video was able to help you out.